So I guess everyone is back from the coffee break. It's a shame that I'm not physically there, and I have to, the screen, the camera is set in such direction that I can't see the participants. I can only see the screen. So anyhow, yeah, coming back to my topic. So first of all, the way Federico spoke in the morning, and he laid the ground for the discussion on these topics like machine translation, and now coming back from machine translation to ASR. It's yeah, that's even better. Yes, thank you. So yeah. So yeah, that was really great the way Federico, and I must thank him and congratulate him the way he delivered his lecture, and I'm really inspired by the way he along with his colleague, both of them were talking, it was really insightful for even me. So the second topic of the day is automatic speech recognition for minoritized language. So coming to the session roadmap. So basically, we have divided this whole session into two half, where first half we'll be talking about the theoretical aspects of ASR, and then we will, if still we have enough time, and definitely we should have, we will go to the hands-on experiment, which I will need you to cooperate with your laptops. So yeah, initially I'll be introducing myself, my background a little, and the motivation about this project. Then we will have a small fun activity on Mentimeter to know the audience a little more better. And then I'll briefly discuss what are the ASR fundamentals. It involves a lot of maths, so I'll skip those part because we all agree that studying maths in the afternoon is not what everybody wants now. And then we will discuss the challenges in the low resource ASR languages, which with some of my personal experience over working for last 1 year, and overview of modern ASR. So how the low resource ASR is different from the traditional ASR, and what are the evaluation metrics. As Federico was also mentioning that for machine translation, we have different metrics. For ASR, we again have different metrics. And again, if you want to work in this domain, what are the publicly available data sets so that you can go back and you can start working on some of them, and how you can improve the data, right? So I will briefly also discuss some of the data augmentation techniques, and the steps to build ASR, right? What are the fundamental steps to design your ASR for your own language, whether it is Basque or Spanish or any other. And finally, we will go to a hands-on session where we have two different agendas on the hands-on session. First is how to use the existing ASR model to do the transcription for a Basque and a Spanish. And then we will try to fine-tune a model to build your own ASR. Right. So this is the whole agenda. And finally, we will have conclusion and direction of future work. Okay, so again, a very welcome to all my participants in this second presentation of the day. So very briefly, this is our team at Max Planck. Me, Paul, and Caroline. Me and Paul are basically, we work on the, Paul is basically advising me on the ASR part. I am a full-time postdoc employed in the project, and Caroline is heading the language development department. She is from a linguistic background. So this is our small team at MPI. Now, a very brief background about myself. I am from India, and India, as you might know, that is a language of, is a country of languages. And as I now living in Europe for last 1 year, I can very well analyze that, Europe with so many languages. Earlier I was only known for the major languages, but now working on this project, I can relate that, all places throughout the world have, they are all rich in languages. And coming from a diverse background like India, I can appreciate the effort which is, led down to improve the minority languages. Okay, so now coming to the first exercise, a little bit of fun exercise. So I want all of you to scan this QR, and this will direct you to some questions which will help me to understand you guys a little more better. So be frank, nobody is collecting any data, your name or anything. So, be open to it. So once you have scanned the QR, I can go back to the Menti screen. Okay, so I will now go to the screen. Sorry, where is the screen? Desktop. Yeah, this is the screen. Let me start the presentation. So I have few questions for you guys. Okay, already some of you have started answering. And why it's not starting? Yeah. So bear with me, like a little bit of network delay. Yeah, so which languages can you speak or understand? Okay, great. So I can see some of the major European languages: English, Spanish, German, French, Catalan. Okay, some of them I can recognize, some of them I don't, but that's the beauty about all of us being at one place. So I'll go to the next slide. Okay, which languages based ASR? ASR is basically your voice recognition, like whether you are using Google Voice or OpenAI voice search. So, which languages do you use mostly in the ASR? Okay, so now I guess the answer will be more filtered. Okay, so it's great to know that, there are languages, there are models in Basque, Catalan, Spanish, which is Polish, great. Dutch, yeah. So I recently moved to Netherlands, and being a non-Dutch, and most of the information in Netherlands is in Dutch, even the public announcement, right? So I have been using language translation a lot for the last, month. And I'm also trying to pick few on Duolingo. I have learned few languages, but still I need to work on my Dutch. So going to the third question, what do you use speech tech for most? Like whether do you do it for translation or do you use it for Google search or chat GPT search? Okay, this is a new term for me, translation. Okay, nice. Whether you are using smart TV and you are using for operating your smart TV, right? Because typing on smart TV is again a very difficult objective. So if you want to access YouTube on smart TV, it's better to go for voice-based search. Information search, text editing, nice Google search, chat GPT. Yeah, so these are some of the application which mostly, we people are using from day to day life. But I'm not sure, maybe I'll ask the participants to make me understand what is Euskara, because I'm not able to understand this term. Okay, so now a very fun question. You have to make a wild guess. Please do not Google. Approximately how many languages are spoken worldwide? Okay, 7,000. Yeah. So, okay, I guess everyone is answering 7,000. Some of might have increased over last few years. 1 million. Yeah, true. It can be. So I have not mentioned the word officially, right? So the number can be anything, but officially there are 7 to 8,000 languages which are spoken worldwide. So most of you are correct. So, your general knowledge is really nice on this. So next question, how many of these languages have text resources? So imagine if there are 7,000 languages, how many of them have written text resources? What do you think the number is? 300. Okay, I'll give you a hint. It's little higher. It's little higher. 600. No, you're going very low. I think you have underestimated the human civilization, right? So the number is a little higher. Yeah, it's close to like 3,000 to 4,000, right? It's close to 3,000 to 4,000. Only the text resources, like they have their own, in the way, like those languages have at least something to write so that they can pass on their knowledges. Okay, now coming to our topic, out of all these languages, 7,000, how many languages do you have a good ASR? When I say good ASR, it means that it is giving me a good recognition efficiency. It is understanding what I'm saying without, with very few errors. So again, you have to make a wild guess, and I am mostly certain that you'll be surprised by the result. But most of you are guessing almost accurately. Okay, so I guess 100 and 200 is the number which most of you are answering. 50, okay. So again, there is a not a unique number, but there is a range. And the answer is like, so on different platforms, they have different numbers, but usually they say 50 to 100. So imagine out of 7,000, we have only, let us take the higher number, 100. So even after taking the maximum number, out of 7,000, we have just good ASR for 100. Now imagine what percentage it is, 100 out of 7,000, right? So it's a very low percentage. So there is a lot of scope and there is a lot of gap where, people, engineers and linguistic can, come together and can start building on this. Okay, so again, it's a little bit of personal question that how often do you use speech tech for different activities, whether you are using it for typing or whether you are using it for Google search, voice search, or doing voice analysis, right? So there are some applications where you can feed your voice and it can give you a report on how quality of voice you have, whether you can become a RJ or a DJ or a singer, right? So there are some application which is doing that also. So it's good to see that most of you are using it on a daily basis, and three are have never used it. So yeah, that's a little bit surprising. I would love to hear from them. But yeah, again, it's a personal choice, so no comment. Okay, so have you ever seen ASR failing to recognize your accent? So if you are speaking a major language, French, English, Dutch, so I guess the ASR will be working pretty fine. But if, like some of you mentioned, that you are speaking languages which are not major, then I think, you might have experienced this. So I can see that, almost like 50% of the group is saying that they have experienced that the ASR is able to not recognize their language. Even I have an Indian accent. So you guys might have problem understanding some of my words because your brain is trained to hear European accent, right? So when you are hearing an Indian accent, it might happen that you are not able to understand some of my words. Okay, so I guess last few questions. Yeah. So how would you feel if your language was not supported by modern technology? So would you feel excluded? Would you feel nothing, like indifferent, or would you be motivated to change it? Okay, it's great to see that most of the people are really motivated. So I am really looking forward to work with these kind of people, right? Because building something of a language needs a lot of community work where people have to come together, which I'll be discussing in my slides, right? That we need people from different aspects of the society. Okay, so 50-50%, like 7 people mentioned they feel excluded, and those 7 people can again join the people who want to motivate it to change it. Because personally experienced, my mother tongue is also not one of the major languages spoken in India. So I have been doing my PhD and research on those languages where I'm trying to, put a digital footprint on them. So yeah, I'm also a part of these 7 people who want to motivate to change it. Okay, now a very tricky question. Should every language have access to speech technology? So you should read the option carefully. Absolutely. Only major languages depend on number of speakers, impact, and funding. So you have to make a very, have to. Okay, so most of you are going for absolutely. That's great. But again, yeah, building an ASR needs a lot of fund, lots of fund for data collection, lot of fund to train GPUs, and only big companies are now able to afford this. So yeah, either like it's good that most of us at least want to, take that step forward and want to build a speech technology in every languages. Okay, so the last question, and then I'll be back to my slides. If speech technology only worked for major languages, who gets left behind? So now you have to do a little bit of brainstorming and you have to write few sentences, few words. Humanity, okay, that's a very humankind. minor language speakers. Okay. Yeah, it's like, it's totally true. I can totally relate to you guys that if suppose I have a language and it doesn't work with the technology, and definitely, I'll feel that, something is missing from my language. And just to add to that, in India, we have so many languages, like 22 languages. And now most of the digital providers, like cricket is one of the biggest sports in India. So most of the telecasters are now giving commentary in different Indian languages. And they have seen that, the viewership has increased because now people can relate more to those, telecast rather than hearing everything in English. So before few years ago, everything was in English or Hindi, but now the new digital broadcaster have started giving commentary in the local languages. So yeah. So with this, I will end this presentation, and then I will go back to the slide. But yeah, this was really an insightful session for me to understand that, so I can see that, we are almost on the same page. We can relate to some of the concepts. And let me go back to my slide. Okay, so we have already mentioned this. So this is the same fact. We have total 7,000. Out of this, 4,000 have text resources. 500 languages have speech data, but only 100 have a very good quality of ASR. Just to give you a more idea on the poll which we had just before. So the question is, why speech technology even matters, right? Why do we want to build a speech technology? So the question is that, yeah, speech is the most natural human interface. Imagine if this conversation I was not speaking, I'm just typing and I was showing you the slide, or it wouldn't have make the more like this kind of sense which is making now. Because with emotions, like with speech, I'm also conveying my emotions. I'm also conveying, a lot of hidden information which simply typing wouldn't have done, right? So what are some of the applications which you can see? Voice assistants, right? So like if you go to any hospital or if you go to any university, if there is someone who can guide you in their voice, like if there is a bot who can guide you with a voice assistant, that would be so helpful. Because, right? Accessibility, like people, like some of them can't have access to reading or writing, or they are disabled. So for them, speech becomes the primary way of communication. So auto subtitle, like even when we are doing this meeting, Teams, Microsoft Teams have this facility that they can, do this auto subtitling. Even if you're using YouTube, YouTube also have this auto caption option where, if you can put it on and you can see the live translation of the people speaking. Healthcare docs. So this is one of the recent research which I saw while I was in Dutch in few of the conferences, while I was in Netherlands in few of the conferences where people are trying to do ASR for a patient doctor communication, and so that they can save it automatically and they can also analyze it and can give insight to the doctors. So this is one area of research where ASR is slowly progressing. Education, like a country like India where people understand different languages, or a country like Europe where we have different languages like Spanish, Spanish, Italian, or Dutch. So if suppose something is in English, right, and it would be very difficult for a non-English speaker to understand it. So if we can do a live translation of the content which somebody is speaking, somebody is teaching, that would be very helpful. And recently, few technologies emerged in the market which is doing that. Call centers, again, like if we have speech translation in call center, like we can talk to people in different languages. And smart devices, like suppose you want to control your home or you want to control a smart TV or a smart car, you can simply do it using your voice rather than typing codes or giving command. So this is why, these are some of the points where I feel that speech technology is really going to change the way people are living now. And already it has been doing it. It's not the past, it's happening now, and it may improve even in the future. Okay, so a few numbers to, just to bring this into more highlight, that there are some research which have found that uh, there have been substantial increase in the voice search, like through Alexa, Siri, you know, over the last few years. You can see these numbers, they're like 72%. Voice search through smart speaker, like increase in 35%. Like when you are going for smart TV, people are no more typing, they are mostly doing voice search, voice command to vehicles, and also like they want to play something. So people are mostly going for voice based commands rather than going for typing. So 71% of the consumer prefer to conduct queries by voice instead of typing. And this is a study which was done by Oberlo. And they reported this study. And I think this study was primarily on the developed nation, not on the developing nation. So here are few more numbers to to motivate you to dive into these subjects a little more. So as you can see here, this is a numbers from past few years. So how this number of digital assistant users have been growing over year and year. And if you talk about the economy, right? So in 2025, the economy for voice based business is 30 billion, and it is estimated a growth rate of 25%. And by 2030, it's like 4 billion. So it's one of the growing market, economic market also rather. So it's have both the side. It has the social angle also, and it has the economical angle also. So when you talk about companies, right, there are so many startups, so many companies which have dived into these areas because they feel that this is the future, right? This is the future. Everybody is investing a lot of money. All these big companies like Meta, Microsoft, Amazon, they have open source a lot of their models so that people use these models and start building application on these models. And these are some of the open toolkit and frameworks. So if you are a beginner in this field, you can just go and check out these links, check out these tools. And, most of them have a lot of academic platform, they have an academic website where they will teach you from scratch to how to build, how to make an SR, how to use it for your own application. So these slides will be shared to all of you, and you can obviously go and look this after this session. So the question is that why is speech technology growing so fast, right? So this is the very obvious question that a few years ago, speech technology was not, it was not everybody's cup of tea, but now it is. So why it is? So the reason is low cost internet and smartphone penetration, right? So now everyone in a family of five, all five of them have have a smartphone. And internet costs have gone down. So, people have more easy access to low cost internet. Explosion of deep learning and transform based learning. So because of this, higher computational, power of these chips, GPU chips, people can now explore these deep learning techniques. We have a platform where people can contribute and collect a lot of huge data, which is used to train our models. Growth of computational power, I have already mentioned that. Open source ecosystem such as Hugging Face, right? So people have developed such platform where researchers, engineers from across the world are coming together. One other reason, which is very specific to country like India, is that a lot of population is illiterate. So, they prefer doing a voice search rather than typing because they might don't know how to type. So in a country where, people are less, educated, the use of voice search is even more higher. So if you look at the numbers between a developing and developed nation, who is using voice search more, you can find this example very evident. Faster interaction, obviously, if you want to type fast, voice-based typing is the fastest mode. And hands-free control, all of us can remember how Iron Man, we were fascinated while growing up, seeing the movie Iron Man, how he was talking to Jarvis, and all of these instruction he was giving, and most of the things was going hands-free. So the summary of all this is that speech technology is the future of human-computer interface, and we have to either use, we will be definitely either a user or will be definitely either who is contributing to this field. Okay, so the next question is that how is it relevant for a conference like or an event like this where we are discussing minority language, right? Already ASR is prominent and dominating everywhere. So why are we, including ASR for minority language? So it is also helpful in revitalizing minority language. So ASR enables speaker to use their language in model digital environment. So if you are using your languages more digitally, so the chances of the new generation learning it is even higher. So that is one reason. Speech technology will help to create digital presence for minority language. So suppose you want to, you want to convert the books in minority language into a digital platform. So if you have these ASR models, so it saves a lot of time rather than doing it manually. Automatic transcription, like for oral traditional folk stories, songs, conversation, all this can be done automatically, and all these activities can actually help revitalize the minority language. So ASR reduces the effort required to create written resources for historical oral languages. Education platform, yeah. So the point which I was making here is that it's very important that the next generation should learn the low resource languages, and if ASR can collaborate with different educational application and can support this language learning for younger generation, like Duolingo. Like if you go to Duolingo, it has most of the prominent languages which are spoken across the world. But if suppose there is a Duolingo for a minority language, right? So even the new generation can even learn those languages more easily. Elders speaker recording can be preserved and transcribed before linguistic knowledge is lost. Yeah, so if we have an ASR and if we have just a recording, we can combine both of them, and we can digitally save not only the audio but also the corresponding text for that. And finally, that voice technology increases visibility and prestige for minority languages. So this was in brief the introduction to the topic. So sorry, can somebody translate that too? Can somebody translate that for me? Okay, I think I have to change the setting somewhere, right? Language and speech.
Arvind,
Yeah.
here in Donostia, presentially, there is no comment. Is there any question? No.
No, I think somebody from online spoke something.
No, and as far as I know,
okay.
No one wrote in
and
the
then
chat.
I will continue. Yeah.
We are controlling it as well. Well, there is a comment about interpretation.
Yeah, like even I listened somebody speaking in Basque, so that's why I stopped. Okay, no problem. I guess there was maybe
this is for interpreters and technicians. There is a comment saying in the chat, we are listening someone speaking in Basque, but I mean everything is right.
Okay, great. So that was till now I have just So till now I have just laid the foundation, the introduction and motivation part, that how is speech tech and how ASR is going to impact minority language, and what is the whole purpose of work package 5 team to to come and work with this whole European funded project where people are trying to work for the minority languages. So till now I have just done that. So the next section is a little more technical, where I'll be discussing briefly about the fundamentals of ASR. What are the okay? So I'll just start with the second section. In case if you have any doubt, you can just you can raise your hand or you can ask the question. So what is automatic speech recognition, right? So all of us remember while we were in school that dictation, right, where our teacher used to come and he used to give spelling to us, and we will hear that spelling and then we will write something on our notebook. Some of them will write very nicely, all of them correctly. Some of them would make a mistake. So what is happening here is that basically a voice signal is entering our brain, and then based on our language model, we are trying to convert that into a text, right? So depending on how good our models are trained, our brains are trained, we will be accurate or inaccurate, right? So in short, if somebody asks me, it convert voice to text. So already I had explained the example. So a little bit about the history. So the first ASR was developed in Bell Labs somewhere around 1952, where people, so I'll just, yeah, so it was mostly rule-based and template-based matching. So suppose you want to identify cat, so they will record voices from cat from different people, and then when somebody new say a word cat, they will do a matching, and then if there is a matching threshold, then they will say that, okay, this word is a cat, right? So it started with a rule-based matching, and then they found a problem that suppose somebody is saying cat and somebody is saying cat, right? So the speed of speaking might change. If depending on their background, somebody might speak, very fastly, somebody can speak slowly. So then they went to DTW, dynamic time wrapping, where it tries to nullify the effect of the speed of the speaker. Whether you speak in fast or slow, it will nullify the effect and it will do a template matching, and then it will come out with the result. Then came a more mathematical concepts for ASR modeling, which is the hidden Markov model. So again, it's a whole, there's a lot of concepts in this topic. So in short, if I'll tell you, there is basically a mathematical based modeling where they are trying to predict the next token of word depending on the current state of the words. So hidden Markov model was pretty much dominant in the last from 1990s to 2010, when the power of the GPUs and the chip industry slowly became more powerful and powerful. So then people started trying out deep learning network, and they found that the accuracy of deep neural network was better than the conventional mathematical model. And now slowly they are going for end-to-end model. And the latest model is the self-supervised foundation model, which is smart enough to understand the whole language by just giving very large amount of audio signal and very few amount of labels. So this is the current state of technology. We will be discussing more in the upcoming slides. So these are the key milestones in this speech ASR domain. Like these are different tools. So Kaldi is one of the prominent tool which people were using around 2000 to 2010. Then deep speech came after 2010, and then after the introduction of transformers, wave to wake, whisper, and MMS. So these are the byproduct of transformer-based learning. So how basically ASR works? So the first input is your speech, right? So if I'm speaking and you are listening, how basically that is happening? So the first input is speech. Then machine will not understand the raw waveform. So it has to be converted into some numbers which the machine will understand. So that is feature extraction. Then comes the acoustic modeling. So acoustic modeling is basically mapping the phonemes. Phonemes is what? The smallest unit of sound. Suppose I'm saying cat, so ka, ta. So these are the three phonemes. Then comes the language model, which varies from language to language. It's basically a grammar, right? It's basically the grammar of the language. And finally, we have the decoding, and it will give you the output as a text. So if I play this sound, right, and if I give this to a ASR, I will expect these kind of output. So when we are doing the hands-on session, we will take the same example. This is, I think, Basque, right? And I'm not sure what is the meaning of this, but eventually we'll be using this audio file and we'll be converting this into the text form. So yeah. So again, very briefly, acoustic modeling basically uses some traditional features, and the pronunciation modeling. Again, they map the phonemes. Language modeling is, as I said before, these are some grammatical rule which gives some statistical based information about the language. And finally, we have end-to-end ASR, which is the very new kind of ASR where we are not using this traditional technique. So these things we will discuss in the upcoming slide. Okay, so again, another diagram where we can understand how this ASR is working. So let me just take a pen. Yeah. So this is your speech signal. And as I was mentioning, the speech is converted to feature. So this is a MEL spectrogram, which is a very prominent feature in most of the deep learning methods. And then these features are, this is a language model and this is the acoustic model. All these three, the language model, the features, and the acoustic model, it goes to the decoding block, and finally it gives you the output. So suppose if somebody is saying cat sits on a mat, so it will be converted to a vector X, and then this vector X will be modeled through GMM, and then using hidden Markov model and GMM and with type decoding, we will decode and we will finally get the output. So I'm giving a very brief. It's if you go and study in detail, it actually there is a whole book based on HMM and GMM. So it's just an overview so that you can just understand these words and then you can go back and read more on this. Now comparing end-to-end ASR with the traditional ASR. So in this traditional ASR, we have seen there were acoustic modeling, there were pronunciation modeling, but here we don't have such kind of modeling. So this is the kind of models which are using for this convention, the deep learning based model like Wave to Vec and Open AI Whisper. So coming to again step-by-step explanation. So step one, as you can see here, this is the raw waveform. This is converted to feature. So in the traditional ASR, we have MFCC based feature, but here we are having 1D convolutional layer like CNN based feature, image based feature, which is trying to capture the local patterns. Then step three is these features are getting converted to latent speech representation. Right, as you can see here in this diagram, the speech signal goes to CNN and then it goes to the latent speech representation. Fourth step is vector quantization, which the whole continuous speech is embedded into a discrete unit. And then finally, this quantized speech representation, they behave like a pseudo phonemes, right? These are not actual phonemes, but these behave like a pseudo phonemes, which then goes to the context network and which finally gives you the prediction, right? So it's the working of end-to-end ASR is a little bit different than a traditional ASR. If traditional ASR needs a lot of label and the audio data, but end-to-end ASR needs mostly a lot of audio data and a very few labels to fine-tune itself. Okay, so the next concept is that, why building ASR is complex, why it needs, so much of, just a minute. Why it needed 50 years to come from, come to a decent accuracy, and why only 50 languages or 100 languages of the world have a good ASR. So this slide will give you the answer. So building ASR, it's not a one-person job. We need people from different background. We need people from signal processing. We need people from acoustic background. We need people from pattern recognition, communication and information theory. We need linguistic because we are designing dictionaries. We need to understand the physiology of our human, voice system, utterance system, how the fundamental voice generation system work. We need people from computer science because it needs a lot of modeling. And we also need people from psychology because speaking involves a lot of mental, behavioral and mental aspects also. So building a good ASR involves coming of, all these people coming together. That's why it's a very complex process. And that's why building an ASR for a new language needs a lot of funding and lots of support from, big companies as well as government. Now coming to our point that what makes the language low resource, right? So there are some characteristics of a low resource language. First characteristic is that there are speech data, but very limited transcribed speech data. So what do you mean by transcribed data? Is that data with the corresponding text part, right? If there are data which is very small or it is very noisy, so it cannot be used by most of the models. It has a few or no NLP resources. Like for example, I was working on Kilivila during my while I was in Max Planck. Currently, I'm working on a Kilivila, so we have a very limited data. The data which we have is very noisy. So most of our models are not giving a good accuracy on those. Okay, and limited funding and community support, right? So even if like we have a lot of speakers, but there is nobody to collect that data, nobody to do the transcription. So even those languages will fall under low resource. Lack of standard orthography. So this is a summary of languages. If we classify into well resource, low resource, and critically low resource, you can see that only 10% of the European languages are well resourced, and rest. Okay, sorry, I think there is some mistake. Yeah. 30% is a low resource and 60% is critically low, right? So here are some examples of low resource languages, and you can also find these examples on our website. And we have classified these low resource languages based on the country. So there is an option to select your country, and then you can see such kind of list of low resource languages. Okay, so these numbers are again just to highlight that most of the languages have almost no digital data. So this is a comparison on the publicly available speech hours, and you can see that for English we have plenty of data, but when you come to languages like Spanish, French, the numbers is going down, and when you come for even like languages like Welsh, Basque, or Breton, the numbers is even less. So with less numbers, our ASR will definitely not work, ideally. So the whole idea is that how we can improve these numbers, how we can collect more data. So the question for discussion is that can multilingual learning reduce the dependency on huge per language data set? So I would like to hear from some of my audience, what is their view on this? Can multilingual learning, like if the ASR model can learn from multiple languages, and will it reduce the dependency on a single language if they share a common phoneme? So if somebody would like to share their input on this. Like no response. So what do you guys think? If suppose we take example of, can you guys give me a name of two languages which have very similar phonemes, which are very similar in identical in their phoneme structure? Because I am not aware of most of the European languages how they sound. But if I talk about the Indian languages, there are many Indian languages, especially in North India, which have almost like similar kind of phonemes. And most of the time, what we do, we build a ASR, one of the language, and then we do transfer learning. Like, for example, if suppose Hindi is a very prominent language in India, but there is another language, suppose Bodo, which is spoken in Assam, like toward the northeastern part. So what we do here, we train a ASR model in one of the prominent language, and then we try to do a transfer learning in another language. So that is really helpful because sometimes collecting data is also is a big challenge.
Arvind, excuse me.
Yes.
You have someone writing in the chat.
Yeah, chat.
And it
yes,
says Aragonese versus Spanish have similar phonemes.
Okay, yeah, with a few exceptions. So yeah, we can. So this is where the research, the linguistic people can help the ASR people, and they can tell these insights. Because as an engineer, we don't know about these aspects, that which phonemes are identical, which phoneme. So if people from linguistic background can, identify that, okay, these two languages have similar background. And if we have a lot of data for one of the languages, definitely we can do transfer learning, and that can help to build ASR for the low resource languages. Yeah. Okay, so I will continue again. Yeah. Okay, so the question is, why is ASR difficult for minority languages? So there are some technical challenges, as I mentioned here. So insufficient level data. So data, as somebody have said, that in the 21st century, data is the new oil. So because most of the, if the language have very limited data, even if I have a GPU, or if I have higher computational, even if I have a supercomputer, my model will not work because I need data, right? So insufficient label data. Code switching, I will mention what is code switching. So code switching is also one of the challenges in most of the languages. As somebody was sharing dialect variation, so somebody in Federico lecture was mentioning that because of dialect or accent variation, the models sometimes have issues in understanding us. Background noise, right? So if we have data, but if there is a lot of background noise, the model is not trained properly on clean noise, even then it's a big challenge, which even personally I am facing, because we have few data set collected long back, but they have a lot of background noise. Pronunciation diversity, right? So if we have data from people and who are speaking the same word in different style, the model may get confused. And lack of text corpora, that there is language, there is audio signal, but there is not proper transcript languages. So coming to the social challenges, so language preservation ethics, right? So community participation, that unless the community want to come forward and engage with the researcher, the researcher can't help them. So this was very much prominent when you are circulating the survey reports. So we were trying to bring in the community, and we have released some videos which were motivating that we are doing this for you guys. So you should come forward and participate in the surveys. Ethical AI and accountability, as again somebody was mentioning in the previous lecture, and somebody had a question also on this, that what are the ethics when we are collecting data for training the AI? So what are the ethics for this kind of work? And who is who has the ownership of the data and the concept? So these are some of the social and ethical challenges which we have to take care of when we are collecting data set from from speakers. Okay, so coming to the code switching challenge, which I was mentioning before. So I'll take two examples, right? So I'll take the second one. I think it will make more sense to you guys. No, it's a Basque Spanish. So, so I can see that, it's a very in some of the words are in Basque, the white ones, and the yellow ones are in Spanish, right? So code switching is also a very common phenomena in multilingual countries. Like in India, as you can see, the first one, and I can read that for you. Today, meeting ke baad, we will submit the report. So today is English. Meeting ke baad is again, ke baad is a Hindi, that after the meeting, we will submit the report. So usually in India also we do this a lot. And I think, Basque and Spanish is also a place where people are, using it in, exchanging both the languages and using it in day-to-day life. Another challenge is mixed vocabulary, right? So people are using vocabulary from different languages. So the model is getting confused whether this is a, Spanish or this is a Basque. Pronunciation variation, as I mentioned before, and rapid transition. So, if there is no proper gap, suppose we are recording something and, we don't ask the speaker to take proper gap or proper space in between, it becomes very difficult to, to set the boundaries. And, because while training the model, we need to set the boundaries that, okay, this is my audio signal and this is the text for the corresponding audio signal. So while doing recording, while creating data set, we have to make sure that we take care of all this. Okay, so very quickly, I will just describe you what is the difference between traditional and end-to-end ASR. So traditional ASR was HMM-based ASR, and current ASR is the end-to-end ASR. So architecture-wise, for traditional ASR, we have different components, but for end-to-end, we have a single architecture. Pronunciation, we need a linguistic, we need a dictionary. End-to-end ASR mostly learned directly from the data. Complexity, it has a complex training pipelines, and it's simpler to end-to-end training. Multilingual, it's very hard. Traditional ASR fails when it is scaled to a new language, but end-to-end ASR does a very fine job when you are doing cross-lingual adaptation. For low resource languages, struggle because there is not enough data. But for end-to-end, it works pretty much good. But if you are an engineer and you want to see the working of individual block, it is much easier for the traditional ASR. But for end-to-end ASR, it is mostly, it's like a black box, which is provided by most of the big companies. So it's very harder to debug, right? Okay, so I guess I'll be moving a little much faster because I have to also go to the hands-on session. So self-supervised learning, this is the latest model which people are using, where we suppose you have a language with a very limited amount of unlabeled data. So you have just an audio signal, but you don't have the corresponding transcription. So in that case, self-supervised learning is very useful, where you have, where you are using these languages, and then you are training the self-supervised language model with just the audio signal. And once it is trained, what you do, you then collect at least 10 to 20 hours of a labeled data. So very small amount of labeled data, and then you do the fine tuning, and eventually you will get a low resource ASR model. So this is currently what most of us are working on, because as I have mentioned before, that low resource language have very less labeled data. So this is one of the prominent models which people are using for low resource languages. And these are some of the models based on self-supervised learning: Wave to Vec, Hubert, XLSR, and Whisper. So these are the four, models which are based on this kind of learning. So these models are really powerful because they are trained over multiple languages. As you can see here, Whisper is trained over across 99 languages. Cross-language XLSR model is trained over 128, and recently MMS, Facebook released the model MMS, which is trained over more than 1,000 languages, right? So you can see how big companies, tech companies, are investing a lot of money for ASR. And so these are some of the advantage of multilingual approaches. Okay, so this is a screenshot from one of the paper for African low resource languages, right? So I was following this paper when I was working on European low resource language, and I can see that most of the models are common, because even they are also facing with a similar kind of unlabeled data issue. So most of the models which they are using, HMM, GMM, DNN, time-based DNN. So all these models are mostly people are using across the world. Just to I just want to show this so that you will understand that these models are not language specific, but it is mostly application specific. So whether you are working on African low resource languages or Asian low resource languages, these models are prominently being used everywhere. Okay, so I guess what is the time? Should we start with the hands-on session? Because okay, so let me just skip all this. I want to, so this is important. So how basically you are, measuring the performance of the ASR. So there is a term of word error rate. So I'll just explain you by an example. So it has 4 components. S is the substitution. So the reference speech is I love speech recognition. And suppose the model gives an output, I love speech recognizer. So there is one substitution. So the word error rate will be, you have to add substitution, deletion, insertion. There is no deletion here, and there is no insertion. Deletion is, suppose if some word is omitted in the result. Insertion is if some new word is added. N is the total number of word in the reference text. So there are 4 words, one substitution. So the word error rate is 1/4. So WER is one of the prominent metrics for measuring the ASR, but for some languages where WER is not easily measured, we have character error rate also, right? So there are some languages where CER is most probably, it's more easy to measure as compared to word error rate. So here are few accuracies which are reported across different research papers. And it's very motivating to see that even for low resource languages, we are getting good amount of WER using some of the latest models. Yeah, so if you want to work on any one of your languages, this slide is basically giving you the name of this open data set. Mozilla Common Voice is one of the prominent data set where people across the world are using, and they are depositing a lot of speech data. These are some of the languages, like some of the database also, where you will find languages specific to European languages like Vox Populi, Libri Speech, Covost. So you can go and check out these data set depending on what language you want to work on. Okay. So yeah, coming to data augmentation, that one problem which I mentioned here, that suppose you don't have enough data, what you can do data augmentation, where you can create, you can have the existing data, you can add noise to it, and you can create some new data. You can also do speed perturbation, where you can change the you can stretch or compress the audio signal. You can do pitch shifting, you can spec augment. So basically it masks some of the random frequency bands. You can also do some TTS, text to speech, and generate synthetic data. And you can also do cross-lingual transfer, like which I was mentioning before, that if two languages are having similar phonemes, you can train it on one language and you can test, you can transfer learning on the new languages. So already I have discussed this. What are the ethical and social dimension of this? Okay, so where is the ASR research going, right? So most of the companies are investing a lot of money in building large foundation models, which can work across different languages. Speech translation, like currently we have few people who are doing live translation of my English to Basque, right? But there are some startups or some companies which want to do it from speech to speech. Like, so a lot of people are also working on this kind of work. Zero shot ASR is basically you give a new language to the ASR, and without any training, it will simply do the translation. On-device edge ASR, like so mobile phone, as I was mentioned before, that mobile phone are very prominent in most of, in everybody's hand now. But when you are trying to use the ASR, most of the time it will need you to connect to the internet, right? But now people are trying to make some models which can work on device, so that even if you're on the remotest part of the world where you don't have internet, you can at least run some basic ASR modeling on that. Federated learning is like training across distributed devices, right? So you will connect a lot of GPUs together and you will share the job across different GPUs rather than putting a lot of pressure on one supercomputer or one GPU. Basically, you distribute the learning pattern. And low power deployment is basically, as I mentioned before, that there is a low connectivity reason. Suppose you don't have 5G connection or 6G. So even if you have a low internet connectivity, your ASR model, your ASR should be working. Few other area where people are working is like for dialect, even if your dialect are different, the ASR should work. Code switching, as I mentioned before, accent adaptation, speech for healthcare, like for clinical ASR documentation, multimodal speech system. Like suppose if there is a camera and there is a voice, so the model should understand your ASR not just by the voice, but also by reading your lips. And finally, there are many startups which are trying to make some apps which will be helpful for people for accessibility applications. Okay, so this will be the last slide before I go to the hands-on session. What are the steps to build ASR, right? So your first step is you have to collect a lot of data in your language. Second is you have to do the transcription, and this is the place where you have to take a lot of linguistic on your team, because they are the right person to do the transcription for you. Then you have to make sure that there is very little noise in your recording. And then you have to standardize the text. Suppose you have suppose in your transcript, you have some characters which are not easily recognizable by the computer. So you have to remove all of them. Then you have to divide the data set into training, validation. So most of the time, you can do it through code also. Then you have to select a model, which model you want to use, like which pre-trained model. And then you have to again, I'm getting a little more technical. So you have to make an appropriate tokenizer. You have to do the sampling. You have to extract the features. You have to map the speech audio to tokenized text. Then you have to give some fine-tuning parameter. train the model on minority language and monitor the validation and evaluation metrics. So once your model is trained, you have to see whether you are getting a decent word error rate or not. Right? So this is the final step. And once you are done, and then you have to iterate. So once you have done the first iteration, you have to see what kind of error you are getting. If your word error rate is not good enough, you have to do some data augmentation. And then finally, you have to fine tune using some additional, domain specific speech. And then you have to test it in the real environment, right? You have to test it with unknown speakers, unseen environment, and then you have to deploy it in the real world. So this is, I think, close to 15 steps to build your own ASR. And yeah, continuously you have to improve and you have to take feedback.